A spacecraft launched 49 years ago, running on a computer with less memory than a modern key fob, just sent back a signal from roughly 15 billion miles away that stopped scientists cold. And if that sentence alone made you want to know more, hit subscribe right now, because this story only gets stranger. Voyager 1 is the farthest human-made object in the history of civilization. It is beyond the edge of our solar system, drifting through interstellar space, the actual gap between stars, and it is still transmitting, still alive, still talking. What has happened to Voyager 1 over the last few years has forced NASA engineers to perform some of the most extraordinary remote repairs in the history of space exploration, while the spacecraft continues sending scientific data from a region of space no other active probe has ever directly explored. The story of Voyager 1 in 2025 and 2026 isn't ancient history. It is happening right now. Thrusters that had been considered unusable for more than 2 decades were brought back into operation. A software patch was sent across billions of kilometers of empty space to work around damaged memory on a computer designed in the 1970s. Instruments have been shut down one by one to conserve the spacecraft's shrinking power supply. And ahead lies another remarkable milestone, one that will demonstrate just how far this tiny machine has traveled from Earth. To understand why Voyager 1 matters so much, start with the distance. Voyager 1 is now roughly 25 billion kilometers from Earth. At that distance, even a radio signal traveling at the speed of light takes more than 23 hours to make the journey in one direction. That means when engineers send a command to Voyager, they don't immediately know whether it worked. They have to wait almost an entire day just for the spacecraft to receive the instruction. Then they have to wait again for the response. A simple test can take nearly 2 days to complete. If the command fails, they have to analyze what went wrong, create another solution, send it across the same enormous distance, and wait all over again. That reality makes what happened in late 2023 even more remarkable. On November 14, 2023, Voyager 1 experienced one of the most serious communication problems in its long history. The spacecraft hadn't completely stopped transmitting. Engineers could still detect its radio carrier signal traveling across billions of kilometers of space toward Earth. But something was terribly wrong with the information contained within that signal. Instead of readable engineering and scientific data, Voyager was sending what appeared to be meaningless information. It was almost like having a telephone connection that was still open, except every word coming through the speaker had been scrambled. The spacecraft was alive. It was communicating. But nobody could understand what it was saying. For months, engineers at NASA's Jet Propulsion Laboratory had to figure out what had gone wrong on a spacecraft sitting billions of kilometers away, using technology that was designed almost half a century ago. There was no possibility of sending someone to Voyager. There was no replacement computer waiting in a warehouse. And there was no way to physically access the damaged hardware. The engineers had only one option: find the problem remotely and somehow work around it. In March 2024, they sent Voyager 1 a command designed to reveal the contents of its Flight Data System memory. The Flight Data System, or FDS, is one of Voyager's onboard computers. It collects information from the spacecraft's scientific instruments and engineering sensors, organizes that information, and prepares it for transmission back to Earth. The requested memory readout eventually arrived. And inside it, engineers found the clue they had been looking for. Part of the FDS memory had become corrupted. The problem appeared to be connected to a single damaged memory chip. That tiny component contained a portion of the information the computer needed to properly organize and transmit its data. Without it, Voyager could still send a signal, but it couldn't assemble the information correctly. The engineers couldn't repair the chip. They couldn't replace it. So they had to find another way. The solution was essentially to move the affected software to different areas of memory and modify the surrounding instructions so the spacecraft could still operate as if nothing had happened. But doing this was incredibly complicated. The available memory was extremely limited. There wasn't necessarily one large empty section where everything could simply be placed. The engineers had to divide the necessary code into smaller pieces, relocate those pieces, and modify references throughout the program so Voyager's computer would know where to find everything. Then came the most nerve-wracking part. The new code had to be transmitted across roughly 24 billion kilometers of space. There was no opportunity to test the repaired system on the actual spacecraft before sending it. The team had to trust their calculations, their understanding of the ancient hardware, and decades of accumulated knowledge about Voyager. The first part of the software patch was transmitted on April 18, 2024. More than 22 hours later, it reached Voyager 1. And then everyone had to wait. When the spacecraft finally responded, the result was astonishing. Voyager 1 had started sending readable engineering data again. After approximately 5 months of corrupted transmissions, the spacecraft was talking clearly. The repair had worked. Over the following weeks, engineers continued sending additional commands to restore the flow of scientific data from the instruments that were still functioning. A spacecraft built with 1970s technology had effectively received a software repair from Earth while sitting billions of kilometers away. No technician touched it. No component was physically replaced. A team on Earth simply rewrote part of the spacecraft's digital instructions and transmitted the solution into interstellar space. And that alone would be an extraordinary story. But Voyager 1 had another problem waiting. The spacecraft needs to keep its antenna pointed toward Earth. Without that precise orientation, its weak radio signal would miss our receiving antennas, and communication with the spacecraft could eventually end. Voyager maintains its orientation using small thrusters. And by 2025, those thrusters were becoming a serious concern. The primary set had effectively been abandoned years earlier. The spacecraft had been relying on backup thrusters for decades. But those backup thrusters were beginning to show signs of restriction caused by residue building up inside their fuel lines. Engineers feared that the backup system could eventually become unusable. If that happened, Voyager 1 might no longer be able to keep its antenna pointed at Earth. The mission could effectively go silent. So NASA faced an unusual choice. They could continue relying on the aging backup thrusters and hope they lasted.